Have you ever just stopped and wondered, why does stuff weigh anything at all? I don't just mean how, but why a tiny little electron has the exact mass it does, and not a single gram more or less? You know, it's one of the absolute deepest mysteries in physics, and today we're diving into a really radical new paper that suggests the answer isn't some new particle, but that it's written into the very shape, the pure geometry of the universe itself. If this is true, it could literally rewrite everything we think we know.
Okay, so let's get right into it. And look, this isn't just some late-night philosophical question. It's a massive, genuine hole in our understanding of reality. It's kind of crazy when you think about it. We can build super colliders and send rovers to Mars, but we can't explain why the most basic building blocks of our world have the specific weights they do. Now, don't get me wrong. We do have an incredible theory. It's called the Standard Model of Particle Physics, and it's brilliant. A huge part of it, the Higgs mechanism, does an amazing job explaining how particles get their mass. Just picture this cosmic field, the Higgs field, that's everywhere. Particles move through it, and the amount of drag they feel, well, that's what we call mass. But, and this is the huge but, while the Standard Model gives us the rules, it doesn't give us the reasons. It tells us the Higgs field is there, but it has absolutely nothing to say about why the electron feels a tiny bit of drag while the top quark feels a whole lot. It's like having a cookbook that lists the ingredients flour, sugar, eggs, but gives you no measurements at all. And this is where the scale of the problem just gets wild. We're not talking about small differences here. The masses of these fundamental particles are spread across 12 orders of magnitude. That's the difference in weight between a single ant and the Great Pyramid of Giza. It is a gigantic, colossal range. And until now, we've had no explanation for it. None. So this is where this new paper comes in and just flips the whole table. Instead of looking for new particles or new forces, it asks a totally different, almost shockingly simple question. What if mass isn't a thing that particles just have? What if it's actually a property of the geometric space they live in? What if you could calculate the weight of reality from its own blueprint? And that question leads to this incredibly audacious claim. The paper puts forward one single, elegant formula. It's not some clunky equation built from tons of experimental data. Nope, it's derived from one core idea about the topology, the fundamental shape of space. And from that one idea, it claims it can calculate the mass for all 12 of the fundamental matter particles. I mean, just let that sink in. Okay, are you ready? Let's pop the hood and see how this engine is actually built. The formula might look a little complicated, but when you break it down, it's really made of 4 distinct and kind of beautiful parts. Each one has a very specific job to do in getting us from the energy of empty space all the way to the mass of a particle. So here's the basic layout. The final mass is just these 4 pieces all multiplied together. The best way to think about it is like 4 gears in a machine. Each one turns, meshing with the next, and when they all work together, a single, precise number pops out at the end. So let's find out what's behind each of these question marks. All right, gear number 1. This one sets the foundation for the whole thing. It's called the neutrino floor. And get this, it's derived from the energy of nothing, the background energy of empty space itself, what we call the cosmological constant. So this first piece establishes the absolute rock-bottom minimum possible mass. It's the ground floor that everything else is built on. Okay, on to gear number 2, the constant sunflower. Awesome name, right? So if the first gear built the ground floor, this gear gives each particle its own unique address. It's a mathematical factor that looks at a particle's specific geometric identity and uses it to place it at just the right starting position on the mass spectrum. Now we get to the heavy lifting, literally. This is the McKay elevator. This is the component that's responsible for that insane 12 orders of magnitude spread we were talking about. It's an exponential factor, so it's like an elevator that takes each particle from its starting address and just shoots it way up to its proper energy level, its mass shell. This is what creates that vast hierarchy. And finally, the 4th gear, which borrows an idea from the mathematical study of knots, of all things, it's called the Reitermeister torsion. This is the fine-tuning knob. Once the elevator gets a particle to the right floor, this factor makes a tiny, precise little adjustment to lock in the final exact value. It's the last little twist that brings it all into focus. So, the machine is built. The 4 geometric gears are in place. Now for the moment of truth. Does this thing actually work? The formula doesn't just give us 12 numbers. It generates a total of 24 distinct predictions for masses. So, how do they stack up against the real particles we've measured in our labs? And here are the results. Let's
just pick one. Take a look at the electron, right there at rank 12. The formula predicts a mass that is ridiculously close to the one we've measured. The ratio is just 1.02. And as you scan down the list, you can see this is not a one-off. Several of these predictions are shockingly accurate.
And right away, this is the first major success. The formula spits out 24 possible masses. And what do you know? Exactly 12 of them line up with the 12 fundamental matter particles we know and love, no more, no less. I mean, just stop and think about that. That in itself is pretty remarkable.
So how good are those 12 matches really? Well, the results are pretty darn strong. 10 of the 12 are at least in the right ballpark, what we'd call within a factor of 3. But look at this. 3 of them are astonishingly precise. They land within just 6% of the actual measured mass.
We have to focus on these 3 because they are just jaw-dropping. The predicted mass for the electron, it's just 2% off. For the up quark, 6% off. And for the muon, another bullseye, just 2% off. To get this level of precision from a formula that's basically just pure geometry, well, that's frankly unheard of.
But okay, it's easy to get carried away with the wins. A good scientific explanation is about being honest, and that means we have to look at the misses too. The formula is not perfect, and where it fails is almost as fascinating as where it succeeds. So the problems really fall into 2 different buckets. First, there's the dead zone. Remember those 12 leftover predictions? Well, 6 of them land in an energy range where, as far as we know, no fundamental particles exist. So are these hints of new particles we haven't found yet? Or are they just noise? Then there's a genuine miss. The formula just completely fails to predict the mass of the second neutrino. It's just a hole in the theory. And then there's one miss that's more than just a gap. It's a direct contradiction. One of the 24 predictions gives a mass that we are pretty sure, based on our observations of the entire cosmos, simply cannot exist as a standard neutrino. This is the most serious challenge to the whole idea, a result that our current data actively rules out. You know, the paper ends with this really beautiful, almost poetic summary of its own idea. It suggests this natural process. The fundamental shape of the universe allows for certain things to be possible, the quantum vacuum of space settles on one of those possibilities, and the formula just calculates the result. The masses, they just land where they're supposed to. So where does this leave us? On one hand, you've got a formula born from pure geometry that predicts a dozen particle masses, with 3 of them having breathtaking, almost unbelievable accuracy. On the other hand, you have predictions for particles that aren't there, a missing particle, and one result that seems flat out wrong. So is this the first glimpse of a profound geometric code that underlies our entire universe? Or is it just an incredibly elaborate, beautiful coincidence? Because if it's real, it would mean the deepest truths aren't about particles and forces at all, but about pure, elegant geometry. And that, well, that changes everything.